Good morning, Lee's Calculus, and welcome again to room 15 where Mary never ends, except on a long weekend. I hope you enjoyed your long weekend. I hope you did some good things. You came back in good health. We still have some recovering going on, but anything exciting over the weekend?
We won against Malakoff.
Yeah. Oh, okay.
15th in the state.
Oh, really?
You didn't hear?
I heard you won. I didn't hear they were they 15th in the state?
No, for cheer.
Oh, okay. I thought, yeah, cheerleader did. Yeah, I heard you go to the state, yeah. Okay. So now what happens is we have the integrals for each of the following. So we're going to just go over some exercises here. And what I want to do is I want to quickly do 1 and 3 and then have you do number 2 here. So, and again, we have the rules of integration. So you have 7 dx. So the integral of 7 dx is going to be 7x. Actually, you could write it as 7 integral dx. That's the equal. And so it's going to be 7 integral of dx is x. And then you have to do what else? Plus c, okay? Our constant of integration. And then over here for this one, we have the integral of x to the 12th power. That's going to be equal to x to the 13th divided by 13 plus c. And so that's number 1 and 3 worked out. So why don't you go ahead and do number 2 quickly? Yeah, if you need, Kaylee, if you need to use, you go. Just let me know if you need to, if something comes up. I saw the picture, the Texas Tech picture up there. That was good.
Yeah.
And there was somebody else going to Texas Tech too, wasn't there? Okay. I think if I were going to go to a big college in Texas, it would be either Texas Tech or Texas A&M. Yeah, and but depending on what the curriculum is, the University of Texas has some great programs. Depending on the program, the University of Texas can be really good too. But I think just kind of the vibe of the campus and all that, I think I'd like Texas Tech or Texas A&M better. That's just me. Okay, for this one here, you should get x to the 6th divided by 6 plus c. Okay, how did you do on that? Kinsey, how did you do on that one? Did you do okay on that one? Okay, so she just says she doesn't know what she's doing. Maybe she wasn't able to follow along, but this is the time where she's going to need some help. And here's the learning pyramid, where we try to, as much as we can, not have as much lecture and have more of this kind of thing. And if Kinsey doesn't know what she's doing, that offers the opportunity for you in the classroom to do what? Teach others, right? So let's try to do that. Okay, okay, Kinsey, you need to explain how it's done. So what we're doing, we're in the section, of course, called anti-differentiation. Let me go to the next one over here, which is called sometimes integration, anti-differentiation. So I'm just going to go ahead and do this one, 4. So what it is, is we have the integral, or the antiderivative. That's what this S-looking thing is, the integral symbol. And since we have the difference of two terms, we can write this up separately, is equal to the integral of x to the fourth dx minus integral of x squared dx. Okay? And now the antiderivative, which is the opposite way, because we have the power rule of differentiation, now we're going to the opposite direction. And so what we do is we take this x to the fourth and we raise this power one more. So 4 plus 1 is 5, and we divide by the power we raised to. So whatever power this becomes up here becomes the divisor down here. And then we have minus, so this is going to be x to the third divided by 3, and we should always remember to add c. And how can we check our work to see if we're right? We take the derivative. So if we take the derivative d dx of all this x to the fifth over 5 minus x to the third over 3 plus c. If we take the derivative of this, we should end up getting to where we started with this stuff here. Well, if you take the derivative of x to the fifth, that's going to be equal to 5. That'd be 5x to the fourth over 5 minus 3x squared over 3 plus derivative of c is 0. Now this is a constant. This stands for a constant. It's just a number. We don't know what it is. It could be any real number, right? And so now we just simplify, and so we get x to the fourth minus x squared. And since we came back to the original place we started, that's a check of the work. Okay? So that's really what there is to it. So go ahead and do parts 5 and 6, and we'll go over those in how many minutes? 2 minutes? 2 minutes. Yeah, it's very, very fast. You should be catching on pretty fast on this. And then it's repetition, getting the experience doing it. Okay, this number 5, you can break out like this, or dt, I said dx, dt, right?
I would like.
So here, we're gonna get t to the fourth divided by 4, plus t squared divided by 2, plus t plus c. Does that look right? Okay. Yes, number 5. And this one here is going to be equal to 3x cubed dx. And so for this one here, we're going to get 3x to the fourth divided by 4 plus c. So that's number 6. Does that look right? Okay. Okay, what I want you to do is go look at 8 and 9. We'll just go ahead and review those pretty quickly. Can you do that? 7, you know how to do 7. And just all 8 does is it complicates things with fractions a little bit. How are you doing, Mr. Carter? Get some help. People to help you. No, but she should be getting help from others, and then she can help you, right?
Yeah.
You should be helping her too.
Yeah, you've been here.
How many think that what we're doing right now is hard? Anybody think that we're doing? You think that's hard? What's hard about it?
I don't understand it.
It was easy until we got to the fractions down a little bit.
Yeah, the fractions and like 7 and up.
So 7 also is hard?
6 and up. I don't know.
So 6 and up? Okay, so you need me to go over 7? Okay. That's fine. We can put the brakes on a bit. That's okay. So here for number 7. So we have 2 integral of x squared dx minus 7 integral of x dx minus 8 integral of dx. Okay, do you see that so far? You see the separation into parts and how that came about?
Yep.
Kaylee, you see all that? Number 7? Okay. And so what you're going to do for this one, the answer is going to be 2. Then you take x, it's called, one thing that I've heard work when you integrate, it's called bump up and divide. And bump up means bump up this power by 1. So that becomes x to the 2 plus 1, which is 3. And divide by whatever you bumped up to. And then for this next one we have 7x, and what's x bumped up? 2, and divided by 2, bump up, divide. And then the last one we hear is minus 8x, then plus c. And so that's number 7 done. Okay? That's not hard, is it? Okay, the thing about it is, this is one of these basic skills, just like basic differentiation, that is, it's absolutely necessary for you to get anything right in calculus, essentially. And if you know, even if this is all you know, that can still help you get a lot right in calculus. Just this, and just the basic differentiation skills. Yeah, everything else, knowing when to do what, that's really important too. So these skills, these basic skills can help you get a long ways.
Mr. G,
Yes.
you know that chicken shirt you gave us?
Yes.
My boyfriend was cleaning my closet for some reason because he has OCD. And he found that chicken shirt and he liked it.
Oh, good. I'm glad he did. Did you tell him he was my dream student?
Yes.
What did he think about that?
He thought it was cool.
Okay, good. Yeah, I saw him over at the Eustis game, but I didn't talk to him. But
You should have went up and talked to him.
I know, but they were like on the other side, and it's not like our stadium is. Like
His
our.
dad is the intermediate principal.
Oh, really?
No.
Well, good. I'll try to talk to him when he's up here. Yeah, good. Well, that's a good suggestion, though. Okay. How's he doing in calculus? He's doing pretty
He's in
well.
college calculus.
He's in
but
college?
He likes it.
He does? Okay, good. What college are they working with?
TVCC.
Oh, TVCC also? Okay, good. Okay.
He loves math. I don't know why.
Yeah.
I used to.
So you used to love math before the letters came into play?
I liked it up until algebra. We took algebra our 8th grade year. I loved that class, and then once I got to high school, I've hated math ever since.
I like
Really?
Miss Tubbs' way of teaching things.
Yeah.
Pardon me?
If I'm going to be
Miss Tubbs?
completely honest.
Yes.
Okay, that's fine.
She's a good.
So what does she do that's, what's the magic of Miss Tubbs?
I really don't remember that class. We take notes like the first half, but we have like 2 periods. In the second half, we would do our work.
And like then we could ask questions or we could ask like our neighbor. Like we actually, like, I don't know how to describe it.
I actually understood.
She wrote things down, whereas you were like, you'll just put the answer up so no one really understands like what we're doing. Like I don't know how to describe it. Like she went more in depth.
Uh-huh. Okay, I have to go watch her observer class or something sometime. Okay, so here we have the next one here.
I don't remember either.
So you have 3/4 integral of x to the 5th dx plus 5/3 integral of x squared dx minus 1/2 integral of x dx. So does everybody see that? Right. So it's separating all these coefficients and separating it all out. Questions on this part here? Okay.
Yes.
So now the bump up divide. So we have 3/4 x to the 6 divided by 6. So I'm going to put 6 right here like this. See that? Plus 5/3 x to the 3rd divided by 3. So I'm going to put 3 over here. And then we have minus 1/2 x to the 2nd divided by 2. and then plus C. And so now it's just simplification from here on out of the fractions. So we have 3 divided by 24, which is 1/8. So you have 1/8 x to the 6th. And can we simplify anything out here? Not really. So we have 5/9 x cubed minus 1/4 x squared plus C. Okay, how many got that one right? So a couple of you did?
Yeah.
Okay.
We need more room for this.
Okay. Yeah. Okay. Yeah, we're really hitting up the trees a lot already, aren't we? Okay. So now, so what'd you get for this one here? Okay, you have the pi equals pi integral x plus, I'll put x to the, what is this, x? Actually, it's, yeah, it's 1 over pi. Let me do that. Plus 1 over pi dx. And this should be dx also, right? And so we have 1 over pi integral of that. So what is this going to be here? Pi x squared over 2 plus 1 over pi x plus c. Okay? They just put pi in there to try to complicate things, but that shouldn't be any complication, should it be? Not really. Okay, let's go ahead to next one here. Yeah, so here we have some other ones. Yeah, these are all good. 10. So do 10, 11, and 12. And we'll talk about these shortly, okay? And help each other with this. Big part of these is knowing, if you just know the laws of exponents. In fact, these are all related to laws of exponents right here.
When we graduate, my graduation cat is gonna be like, I would like to thank these sponsors and some of the Quizlet, Socratic. We do it all over. Socratic is the laziest way to
Socratic?
What's
Socratic.
God,
I don't know
who
what that
said
is.
that?
You gotta do Socratic method?
method? Yeah,
No?
We've done it.
We've done it?
yeah, yeah.
It's an actual.
Oh, purple
Yeah,
pencil.
it is.
but
Oh, I know, but, yeah. Yeah. Yeah, that's okay.
You have to convince each other of the right answer.
You know about Chang too?
Isn't that the dog delivery?
Yeah.
What's that one called?
Chewy? Wait,
So Herman, how are you doing this
That's the secret.
one? On these columns here, right?
she's writing it down.
10,
That's good.
11, 12. How are
She's
you?
actually writing it down.
How are you doing?
Yeah, I'm writing it down.
I'm there, I'm watching.
I'm watching. Don't do that.
Okay, but here, just watching, let's go back to the learning pyramid, right? Okay, just watching, that's this stuff here, right?
Yep.
you're trying to do this stuff here, discuss, practice doing, teaching others,
Oh.
right?
Wait, what? Demonstration or
Teach
lecture needs to be
others.
bumped up above teach others.
Wait, are we supposed to teach others?
Yes.
Yeah, this is where more
That's
learning
philosophy.
happens, right here. And this is why, when I try to do this is why the class goes slower than our college
Yeah, I
class.
think we should just.
Go spend more time here.
No,
We should
I don't wanna
read
read,
your
no.
way.
Oh, yes.
And if I'm talking the whole time, it's this. And so you might hear a few things I say and all that. And some other, have some other tools, right? The songs and stuff like that help memory. In fact, this thing right here, never should forget to add the C. Right here, with Indefinite integrals are solution generals, so you should never forget to add the C.
I almost forgot about that song until I just pulled it up.
Yeah, so that's part of the memory bank, I hope, of what you should be able to access at some level.
A Sharpie should choose off.
I've heard it.
Oh my god.
I've never seen it.
Put it in his room.
It hit my bike, I've heard it bounce. Like that. Crack my leg.
As long as I don't get business.
And what? What's going on? Maybe she should.
What would you do?
Would you like, wait, let me go.
I'll pop your arm. Probably on the ground.
What shoes are you wearing?
Those are Dickies.
I think I was gonna put like.
Okay, for number 10, what we have is integral of x to the negative 2 power dx. Does everybody see that?
Yeah.
Everybody catch that? So our answer to that's going to be x to the negative 1 divided by negative 1 plus c. So it's going to be negative 1 over x plus c. Does that look right?
Yep.
Okay. Questions on that one? Okay, number 11, what we have here is 4 x to the negative 3 dx minus 5 x to the negative 4 dx. Okay, does everybody see that?
Yep.
Okay, next thing we'll do is just do the integration for x to the negative 2 over negative 2 minus 5. We have x to the negative 3 divided by negative 3 plus c. And so that's going to be equal to negative 2 over x squared plus 5 over 3 x to the negative x to the third power plus c. Does that look right? That's right?
Yeah.
Okay. Part of the reason I asked that is for you to catch any mistake I might have made. Because might I make a mistake or two here?
Wait, I'm confused.
Yes, what's,
On the top, on the floor one?
on the 4 here?
No, down, right there.
Okay.
With the 2, did you have to get the negative 2 on top?
Okay, what it is, it's bump up divide. So negative 3 plus 1 is negative 2. And then you divide by negative 2. So you see that? That negative 2 plus 1.
So it's not the negative 2 going into the 4. I was thinking the negative 3 should go into the 5, but you just moved it down.
Yeah, I just put it over here. I put the negative 2 over here. Because we bumped up from -3 to -2, and then we have to divide by this -2.
It's like split.
So that's where that comes from. Is that your question? Is that your only question? How many got this one right?
Nope.
So one person
Kids are getting better.
got this?
Like your arm.
Really, one? Okay. So seriously, one person got this right?
Yeah, I was in.
Okay. The people who didn't get it right, do you know what you did wrong?
Yeah, I know.
Okay. Go ahead. Okay, then this one here, you have, this is going to be the integral of x to the 1/2 power dx. So what that's going to be is x to the 3/2 divided by 3/2, which is the same as multiplying by 2/3 plus c. And so you could leave it like this is a qualified answer, or if you want to go ahead and put 2/3 square root of x cubed plus c. You can write it like that too, but they're both the same thing. So when you do these radicals, when you divide by this, it's the same as multiplying by the reciprocal. You'll see that. It's again, it's getting the hang of it, getting the practice at it. And people will do these in their head. Now these ones right here, I happen to have worked out this number 14. So what I want you to do is, I want you to do number 13. This is number 14 all worked out. Let me put this over it. So that's number 14 all worked out in blue. But go ahead and work out number 13. Okay. Okay, for this one here, we have 2 times the integral of y to the 1/3 power dy minus 4 y to the 1/4 power dy. Does everybody see that?
Yep.
So what we have is 2 y to the 4/3 divided by 4/3 minus 4 y to the 5/4 divided by 5/4 plus C. So here, we're gonna have 3/4. Actually, we're gonna 3/4. We're dividing by 4/3, we multiply by 3/4. 3/4 times 2, y to the 4/3. So we'll come back on this tomorrow. I'll save this and we'll come back on this tomorrow.
Flexible the hand.